and we just completed our family trees. And so what we learned from our family trees was that you can show how things are related and show ancestry. And that's pretty much what phylogenetic trees do. So in biology, the main idea behind evolution is that all life derived from one organism. So everything on Earth is related because we all came from a common ancestor. And that's why biologists create phylogenetic trees. Phylogenetic trees show the evolutionary relationships between organisms. So, and they do that based on characteristics or traits. So to relate that to our anticipatory set, our family tree illustrates how you and your cousins share a common ancestor in your grandma. This phylogenetic tree shows how phones have evolved over time. So here is our phylogenetic tree, and this one we're going to do it not with organisms but with phones. All right? So the oldest organism or phone would be a crank phone. Does anybody know how a crank phone worked? Did anybody? So a crank phone, you would have to crank it, and you would pick up the earpiece and you talk to an operator to connect you to the individual you wanted to talk to. After a while, we developed self-dial phones. So crank phones don't possess this characteristic. So as you go on a phylogenetic tree, this diagonal here represents time. And these little dashes represent a different characteristic. And every organism on the other side of this dash possesses that trait. So every phone, as we go on upward in time, like on the phylogenetic tree, possesses self-dial. So you can self-dial on a rotary phone, you can self-dial on the touchstone, you can self-dial on a cordless phone, cell phone, smartphone. All right, so the different organisms, in this case we're talking about phones, but organisms are located across, so you guys can follow along and fill this in on your worksheets, are located across the top of the tree diagram. So here are our organisms, all of these guys. And along the diagonal are our different traits. Okay. These are our traits. And this also represents time. So the further we go back, the older the organisms. They possess less of the characteristics. So if two organisms, phones, are located next to each other on the tree, it means that they are more closely related because they share more traits. Okay. So when a new trait appears, every organism that evolved after that point possesses that trait. We've already established that. So maybe we can go over these questions on here. What traits on the diagram does the rotary phone have? So you guys take maybe half a minute to figure that out. Does anybody know what trait a rotary phone has? Yes, Kimberly?
Self-dial.
Yes. So rotary phone possesses a self-dial trait. Does it possess an electronic punch down?
No, because it's after.
Yeah, because it's after. And its individual history branches off before that trait. So what traits on the diagram does the flip phone have? So the regular cell phone, not the smartphone. Boyd?
Cordless.
Yep, it's cordless. Anything else? Nicole?
Electronic punch dial.
Electronic punch down. Rachel?
Cellular.
It's cellular, yep. And it's also self-dial. So it possesses everything on here except for internet access. So it appears after cellular but before internet access. Okay. So the next part of this, we're actually going to look at the phylogenetic tree with organisms. So we have a chart We have a ray fin fish, amphibian, primate, rodents and rabbits, crocodiles, and birds. Right? So down the diagonal we see our characteristics, and across the top is our organisms. So in each of the following sets, choose the pair of organisms that are most closely related. So you guys can take a minute and you guys can tell me if rodents and birds are more closely related or if amphibians and crocodiles are more closely related. And also if primates and rodents or ray fin fish and amphibians are. So go ahead and take a minute to do that. When you guys think you have the answer, please raise your hand. Does anybody know if rodents and birds or amphibians and crocodiles are more closely related? Anybody want to guess? Nicole?
Rodents and birds.
Rodents and birds. Yes. Why did you say that?
Because rodents, there's only one animal between them and birds, and then amphibians, there's two between them and crocodiles.
Yeah, so you can look at it that way. You can also look at it by their traits. So amphibians and crocodiles, they share 3 traits in common. They're both vertebrates, they both have bony skeletons, and they both have 4 limbs. They don't possess an amniotic egg. And if we look at rodents and birds actually share 4 characteristics. They're both vertebrates, they both have bony skeletons, they have 4 limbs, and they also have amniotic eggs. So based on that, you're right. It's rodents and birds. So what about the next one? Primates and rodents or ray fin fish and amphibians? When anybody thinks they know it, just raise your hand. Yep, Kimberly?
Primates and rodents.
Yeah, primates and rodents. Why do you say that?
Because they're on the same branch.
They're on the same branch. How many characteristics do they share?
5.
5. And how many characteristics do the ray fin fish and amphibians share?
2.
So based on that, yeah, you're correct. It's primates and rodents. So I'm going to give you guys a minute to fill out the next few questions on here, and then we'll go over them as a class. Right? Just let me know when you guys think you have them done. All right, guys. Which traits appear on the diagram?
6.
6. And which traits from the diagram do amphibians have?
4 limbs. Bony skeleton. Vertebrae.
What about birds?
All of them.
Does it
It's not hair.
Doesn't have hair, right? It has everything
Not hair.
else. What about primates?
Hair, amniotic egg, 4 limbs, bony skeleton, and vertebrae.
Thank you. Right. So, organisms that have the most traits branch off last. Would be. So if you possess the most traits, you're further down the timeline. You're further down the phylogenetic tree because it takes time to evolve those traits. So organisms that have the fewest traits branch off first. Crank phone doesn't possess any of them. Rotary phone only possesses 1. Touchstone only possesses 2 characteristics. So if 2 organisms have very similar traits, they should be close together on the tree. If two organisms have very different traits, they should be farther apart on the tree. So the last one, does anybody want to fill in the blank? Does anybody think they know? Traits that lots of organisms have evolved. Traits that lots of organisms have evolved many years ago, right? Long ago, whichever one you want to do. And traits that only a few organisms have evolved.
Recently.
Yes. Correct. All right. So that's our background, and now we want to get into our actual main activity. What we're going to do is, based on what you guys learned, we are going to make a phylogenetic tree with candy, right? So we're going to get in groups of 2, and you guys are going to try and sort out this candy based on its characteristics, and we will come back together and see what you guys come up with. So make sure your worksheets are all filled out and turn those in to me. Okay. We are going to continue our activity from yesterday. So our learning targets are still going to be the same. I can make a phylogenetic tree using an amino acid sequence. I can make a claim as to which 2 organisms are most closely related based on genetic evidence. So before we get into our main activity, I kind of wanted you guys to help me out. I was collecting water samples this weekend at Nananum Pond, and I came across these weird little organisms, and I was hoping you guys could help me put them into a phylogenetic tree. So if you guys could get into groups of 2. So I can start off the first 2 for you guys. So this is kind of another way to make phylogenetic trees, and this is helpful when you have a lot of characteristics to deal with. So these are our organisms lined up. And so if you guys can give me some of the characteristics you guys see in those organisms, I can write them down, and I'll show you how to set up the table. So what's one characteristic?
Circular.
Circular membrane. Does anybody have another? Yes?
Some of them have little hairs coming
Yep.
off the top.
Hairs. Are they both the same though? Is there 2 different traits for that?
Some of them have more hair, and some of them have less hair.
So hair, and then we'll say plush hair. Does anybody else see any other traits? Yes?
There's teeth.
Teeth. Yeah. All right, what else, guys? Yeah.
Eyes.
Eyes. What else? Yes?
Square.
Square.
Or
So,
square-ish.
yeah, so we're going to say circular or non-circular. So that can actually
okay.
go there. So that one's actually, and which organism is square?
F.
F. So F actually does not possess circular membranes, so he would be a 0 for that trait. Any other characteristics that we see? So there's, some of them have eyeballs, right? So we got that, and some of them have colored eyeballs. So let's put that. And anything else? We got plush hair.
No teeth.
No teeth, just a mouth. So I think we got all of them. So what we can do is go through for each organism and state whether or not they possess that characteristic. And if they do, they get a 1. And if they don't, they get a 0. And at the end, we'll total them up, and I will show you guys how that's going to help us set up our phylogenetic tree. So let's go ahead and do that. For A, is A circular?
Yes.
Yes. Does A have hair?
Yes.
Okay. Does he have plush hair?
No.
No.
Does he have teeth?
Yes.
Yes.
What about eyes?
Yes.
Yes.
The color.
They're colored. And a mouth.
Yes.
All right. So let's count these out. He's got 1, 2, 3, 4, 5, 6. What about B? Is B circular?
Yes.
Does B have hair?
No.
Does B, so no plush hair, because he doesn't even have hair. What about teeth?
No.
Eyes?
Yes.
Colored?
No.
Mouth?
No.
All right, so B is 2. What about C?
Circular.
Yes. Hair?
Nothing else.
Nothing else. All right. So he's 1. And D? Is he circular?
Yes.
Hair?
Yes.
Flush hair?
No.
Teeth?
No.
No.
Eyes?
Yes.
Colored?
No.
Mouth?
Yes.
So he has 4. Let's go over to E. Is E circular?
Yes.
Hair?
Yes.
Flush hair?
No.
Teeth?
Yes.
Eyes?
Yes.
Colored?
No.
Mouth?
Yes.
So we got 5. F.
Nothing.
F has nothing, right? Okay, so one thing we didn't learn the last 2 days about phylogenetic trees is an outgroup. And an outgroup means that it's an organism that doesn't contain any of the characteristics on our phylogenetic tree. So we call it an outgroup. And most likely it's the oldest organism of our phylogenetic tree. Right? So F is our out. He's going to be the first one on our tree. So G. Is G circular?
Yes.
Hair?
Yes.
Flush hair?
Yes.
Teeth?
Yes.
Eyes?
Yes.
Colored?
Yes.
Mouth?
Yes.
All right. Got everything. All right. H is circular?
Yes.
Hair?
No.
No.
Flush?
No.
Teeth?
No.
Eyes?
Yes.
Colored?
No.
Mouth? Yes? So we have 3. All right. So right here, these are our traits. And what we learned a couple days ago is that our traits on our phylogenetic tree they go along the diagonal. So these are going to be our traits. And then our organisms are here, and they go along the top, right? So what did we say was our outgroup? F. So F is going to be the first guy. This is his history right here, and he does not possess a circular membrane, so he is out. He is first. He's most likely the oldest of the organisms that we're looking at today. What comes next? How do we know what comes next? Whichever organism for our totals here has the fewest is the one that's going to come next. Because as you move on in time, you develop more characteristics. There's more time for natural selection to occur and for species to evolve. So the organisms at the end of our phylogenetic tree are going to be the most derived. They're going to possess the most characteristics. So right here, we're going to have the organism that has the most characteristics at the end, which is what? G. And we're going to fill in the rest. And we'll fill in these as we go. So the next organism is going to be, so we have 0. Who's 1?
C.
C. And C has a circular membrane, but what does he not possess?
Hair. Or anything else.
Anything else. And who's 2?
B.
What does B possess that C doesn't possess?
Eyes.
Eyes. So the next one's going to be eyes. And that was B, right?
Mm-hmm.
Who's 3? Where do we find 3?
H.
H. What does H have that C doesn't have? Right. So mouth is going to be the next characteristic. And then we have, what's 4?
D.
D. What does D have that H doesn't possess? He's got a membrane. Hair. All right. So hair. Where's 5?
E.
So let's compare E and D. Teeth. So what's left? 6.
A.
A. What
Colored.
colored eyes? All right, so that is our phylogenetic tree for these guys. Does anybody have any questions? No? All right, so now we can get into our main activity. So today we are going to be talking about, we're comparing two different scientific theories. So we're going to be talking about a theory proposed by Jean-Baptiste Lamarck, and it was called acquired characteristics. And another theory that we kind of talked about yesterday, which is Charles Darwin's theory about natural selection. And both of these theories kind of discuss how organisms change over time. So these guys were both naturalists and biologists, and they were alive during the 1800s. And in the 1800s, people never thought about animals as changing. They always thought, like, a chicken is a chicken, and it was a chicken 10,000 years ago, and it's going to be a chicken 10,000 years from now. They never thought animals change, and why would they, right? Because evolution is such a slow and gradual process that we never get to see it in our lifetime. So why did they? We actually do see evolution now. We can see it in bacteria. So like antibiotic-resistant bacteria, that's evolution. That's something that evolved during somebody's lifetime. It happened very recently. Also, some biologists who have studied finches, they've studied them their whole lives, so they've gotten to see like 50 generations of finches. They've seen signs of evolution. But normally, we don't see it. It happens so slow, we just don't see it. So why did these two men think that species changed over time? Well, Charles Darwin, he took a sea voyage across the globe, and he stopped at island to island, and he was taking very detailed notes. And he was looking at all these organisms, and he noticed they all possess the same adaptations. They all kind of look the same, even though they're separated by thousands and thousands of miles in oceans and continents. And he thought about that. Why is that? Why do they look the same? Why are they so well adapted to their environment? And he thought it must be some mechanism in nature that's pushing them to change, to get better, to be able to survive, to be more efficient. And Lamarck thought the same thing. Lamarck thought that an organism fought to not become extinct. So both their theories were that species change. They changed in the past, they're changing currently, and they will change in the future. So they both agreed on that in their theories. And they also thought that it was because of the environment. It was something in nature that was pushing them to change. But that's where like their similarities end. So we're actually going to look at their theories a little bit closer. You guys are going to pair up, and you guys are going to read their theories in more detail, and you guys are going to answer some questions about those theories. You guys, we're going to answer these questions based on your reading. So, organisms changed over time. Did Darwin believe this? Did Lamarck believe this? Or did they both believe this? Kimberly?
Both of them.
Both of them, correct. I'm going to give it a B. What about the next one? Organisms changed because they wanted to survive. Nicole?
Lamarck.
Yep, Lamarck.
Lamarck.
Good job. So, number 3, there was variation in the population. Boyd?
Darwin.
Darwin, correct. Okay, what about number 4? Certain traits helped organisms survive and reproduce better than other organisms without those traits. Who was that? Rachel?
Darwin.
Yeah. Okay. Number 5, organisms can never become extinct. So, who thought that? Boyd?
Lamarck.
Lamarck thought organisms can never become extinct. So number 6, the environment had something to do with why organisms changed. Kimberly?
Both.
Yeah, they both thought that. 7, parents are able to pass on at least some of their traits to their offspring. Nicole?
Both.
So number 8, parents are only able to pass on traits that they were born with. Who was that? Rachel?
Darwin.
That was Darwin. Number 9, organisms could decide to change something about their body and pass on that change to their offspring. Who's that? Lamarck.
Lamarck.
Yep, that was Lamarck. And the last one, organisms are still changing. Who thought that? Boyd?
Both.
Yes, both. Okay, so now the next activity we're gonna go into, you guys are gonna look at these elephants, and they're scrambled, but they both depict Lamarck's theory, and one of them depicts Darwin's theory, and you guys need to unscramble them and tell me whose theory is being depicted in these pictures. So you guys are gonna pair up and do that.